finish up this information about the red blood cells. All right, so we've kind of seen the production of them. So when they have met their lifespan, which is usually about 120 days, for the most part, they die in the spleen. When you look at the structure of the spleen is reticular in formation, meaning that's one of the three fibers of the body. And when you look at the reticular fibers, they create this really sticky, like web type, it looks like the little tiny branches of trees that create all this stuff that can catch. And so every time those red blood cells go on their circuit around the body and get pushed through the capillary beds, they're getting worn out. So by the time they get to roughly about that 120 days, what will happen is they'll get stuck on some of those fibers in the spleen and simply break apart. So they break down by hemolysis, breaking apart, splitting, okay? Now, here's the thing. The makeup of those red blood cells, because they have tons of proteins, that means they've got tons of the amino acids. They've got a heme group. They've got an iron group. We can't just simply let all of that go to waste. The body will take what it can and recycle the components of the red blood cell so that it can reuse it to make more. So the cell parts are digested by macrophages. Hemoglobin, which has the iron on it, macrophages will separate the heme, that looking molecule on the hemoglobin. So it'll separate the heme from that amino acid chain, which is the globin. That amino acid chain, those amino acids can actually get broken apart at their peptide bonds and sent back into the bloodstream and make their way to cells that can use those amino acids again. Iron from that heme group returns to the blood and combines with transferrin, the protein for storage in the liver. So the iron will go to the liver. The actual heme group, that part that looked like it was four corners on the globin molecule, it's going to convert it to something called biliverdin that contains or converts to bilirubin. Ever heard of bilirubin?
Did last night.
Yeah. Something with the liver. Do y'all know what it's in relationship to? Jaundice? Yes. Okay. They'll check bilirubin levels for jaundice. Okay. This is where it comes from. That means it's these products of the red blood cells breaking down. Now, what it should do, okay, the bilirubin from that heme group, it should go to the blood, bind to an albumin.
I thought jaundice was caused by ammonia in the blood.
Actually, it's this product, the bilirubin, from the heme group. Albumin is a major protein in the blood. It's one that's in a very high count. in the blood. So the bilirubin should bind to the albumin, make the way to the liver, where it should secrete the bile and therefore go to the gallbladder. And under normal conditions, make bile pigments. Color. Bile in the gallbladder is very darkish, greenish, very yucky looking, okay? However, very important, okay? We need it for breaking down the fats that we consume in our diet. Now, the bile that goes to the small intestines, because we have a bunch of beneficial bacteria in our intestines, it should convert it to something called urobilinogen. Make its way through the intestines, become part of the feces, and this is what helps to give the brownish color to feces. So under the normal conditions, these are the processes that should be taking place. For urine, it gives us urochrome, which will give the yellow color to urine. Jaundice is when this process of breaking down the heme isn't going correctly and gives the yellow color, because that's the major color from it. It gives the yellow color, and it ends up showing as like the why the eyes get yellow, the skin gets yellow, this sort of thing. And that's when they know there can be, most of the time it's indicative of something going on in the liver. In babies, a lot of times, you know, they end up with jaundice. They have many ways that they can help it. The biggest one is, you know, they put them under the light, which helps to break down the chemicals, and then they get to urinate and poop out the chemicals from the jaundice. So for babies, you know, they make sure that they get plenty of the fluids and that sort of thing. Usually they end up being okay. Earlier, before we found out ways to help it, actually people died from this. So now we pretty much are good on it. Just like everything else in the body, we are going to have disorders. Now, in the grand scheme of things, all right, it's our job to start with the digestive system, the stomach acid, and then getting our iron, and then we're going to produce our erythrocytes, and then they've got to break down. So this right here is basically a schematic of showing our, you know, blood production, our usage of it, the death of it, and then the breaking down and the components that get returned so that we can reuse them in the body. There are disorders that are, well, yeah, pretty common with the red blood cells. One is called polycythemia. This is where you're going to have a high count of platelets. And that begins to create issues if it goes on and becomes something that is chronic. All right? Anemia is where we're just, you know, that hemoglobin, that iron in the blood is not sufficient to pick up oxygen to carry that oxygen to the tissues. Sickle cell disease is where there's a, like I said, it happens on that amino acid chain at the level where it's at the 6th amino acid, and this is where we end up getting misshaped red blood cells. Now, sickle cell disease, it's termed a disease that is widespread throughout the body. Think about it. If the red blood cell is shaped incorrectly, that means it gets stuck in the tissues of the body. Okay, it actually gets stuck. And because that happens, And we've got tissues throughout the entire body because we're nothing but cells, and cells make up the tissues. Therefore, it affects many areas of the body. It affects the eyes, it affects the heart, it affects the liver, it affects joints. I mean, you name it. It has the ability to affect any area of the body.
Do you know why it's more common in minorities?
That's because of the origin for it. And the origin is from Africa. And one of the things that happened, it was actually a evolutionary adaptation, because what happened is the mosquitoes there, of course, pass along malaria, and the ones who had the sickle cell disorder were not affected by malaria. So it was actually an evolutionary adaptation, which of course, not being in a situation where technically malaria is an issue, but still, even in that adaptation, it causes a lot of health effects because of all the different tissues it can affect by that red blood cell getting stuck. So, we're going to stop right there for today. We'll pick up at blood types for tomorrow. In lab for today, I think we're on, is it lab 25?
I think it's
26. The one for blood? Okay.